sections 2.8 and 3.2 both deal with linear inequalities and systems of linear inequalities. So a few basic elements that we need to make sure we do this correctly. Linear inequality simply means you have the less than or equal to, greater than or equal to sign. So you don't have the equal sign. That's what that is. When we do linear inequalities, there's only one method that you have, and that's graphing. That's the only method you get. There is no substitution or elimination for linear inequalities. So with the linear inequality, you'll graph it as if it was an equation with one small change. If you have less than or greater than, you'll have a dotted line, dashed line. Less than or equal to, greater than or equal to is a solid line. The type of line you have is important. Less than or greater than means nothing on that line will work for the problem. You can use it to graph it, but then after you graph it, nothing on that line will satisfy the problem. Less than or equal to, greater than or equal to, everything works. Also notice that one side is shaded, one side is not. With inequalities, you will be shading. So, ironically enough, this is definitely caters to those of you who like to use colored pencils, highlighters, things of that nature. Make your work a little colorful. One thing I would strongly suggest you use, though, is a pencil. Strongly use a pencil. So what we're going to do today is we're going to start by graphing one inequality on a graph. We'll move up to 2. We'll graduate to 3. And then look at a word problem of how we put this into practice. So, any questions before we move forward? Let's start by graphing a single inequality. So to graph a linear inequality, graph it as if it was an equation. Use a solid line for less than or equal to, greater than or equal to, dashed line for less than and greater than. So since we're graphing, our primary focuses will either be on x equals a number, which, remember, is a vertical line. Y equals a number, which is a horizontal line. And then if you have a diagonal line, slanted line, then that means you're in some kind of y equals mx plus b situation. So slope-intercept form will get used. So first step, for example 1, x greater than or equal to 4, we graph it as if it was an equation. So in this case, go to the x-axis, go to 4, and then since it's greater than or equal to, you're going to draw a solid line. So you graph a solid line. Now, we choose a test point. So we choose a point that lies on either side of the line, but not on the line. So you can pick whatever point you want to test, because we got to see which side is going to get shaded. which place you pick doesn't matter, don't care. The only thing you can't do is be on the line. So since x is greater than 4, I'm going to pick where I think it's going to be greater than 4. So I'm going to choose that point right there, which is 1, 2, 3, 4, 5, 6, 7, 1, 2, 7, comma 2. Why did I pick that point? It felt like it. All I have to do is pick a point somewhere. So x is 7, y is 2. We're going to take those numbers and plug it into the problem that we had and see if it works. If it works, this is where we shade. You can pick any point on any side of the line, on either side, as long as it's not on the line. Pick any side you want. So now we're going to plug the point in, and we're going to see if it works. So we're going to test 7, comma 2. So x is 7, if 7 greater than or equal to 4, that's true. 7 is greater than 4. So that means if that point works, any point over there is going to work. So that is where we will shade. So you shade everything on that side of the line. And that's it. Problem's over. So that means if this point didn't work, then we would have shaded on the other side. So something's got to get shaded. Question, example 1. Alright, let's move to example 2. Something's in the chat here. Jeremiah, you're fine. Example 2. 6y minus 3x is greater than 15. So first things first, we have to get this in the slope-intercept form. So 3x has to move over. 6y greater than 3x plus 15. Divide everything by 6, so your y is greater than 3 over 6x plus 15 over 6. That's y greater than 1/2 x plus 2.5. So first thing is rewrite it. So in terms of showing your work, yes, please show me that you rewrote it. Now we graph it. Y-intercept is 2.5. Plot that on the graph. Slope is 1/2. Up 1, right 2. Again, when we graph, we want as many points as we can so that we can have as straight of a graph as we can. Since you have a greater than sign. Greater than sign means you're going to have a dotted line. You should have a broken line. So you should have a straight line. And you should have a dotted. Questions before we continue? Now it's time to pick a point. So again, you choose a point that you think works. Choose a point where you think it works. So I'm looking at greater than. So now when it's a slanted line, it's either you pick a point above it or you pick a point below it. Since it's greater than to me means above, so let's pick a point that's above this line. Choose that point right there. 1, 2, 3, 4, 5, so that's 0, 5. Yes, the point that you pick is purely arbitrary. It's purely arbitrary. You're selecting the point. So after you select the point, now you test it. So we're going to test 0, 5. That's 6 times 5 minus 3 times 0, greater than 15. So 30 minus 0 is 30. 30 greater than 15 is true. So that point works. You can pick any point you want as long as it is not on the line. So you can pick a point above it, pick a point below it. So since this point works, everything up here is going to work. And that's where I would shade. That's the end of the problem. So what that means is, since there's 26 different people in this class, there could be 26 different points that get tested. You have to show the work for what you tested, because I don't know what you're going to test. Questions, 1 or 2? Again, I am doing it a lot slower than how some of you are going to do it. Some of you will be able to move through it pretty quick. All right, so that's 1 point. So that's 1 inequality. So if you can do 1, then you can do 2 of them. Now we're going to do 2 of them. So 2 inequalities means something is going to get shaded twice. Something's going to get shaded twice. Now, if that doesn't happen, then the answer is no solution. But something should get shaded twice. So if you look at the example that they did for you, x less than 2, everything to the left was shaded in red. Y greater than or equal to -1, everything was shaded in blue. So it leaves this little piece that's in purple. So if you take an arc, red plus blue, red and blue mixed together, purple. The purple rectangle is what the answer is to this problem. So everything in that rectangle satisfies both inequalities. So I can pick any point out of there, and that's the answer for the problem. So that's what we're looking for in terms of an answer. We're looking for something that is shaded twice. Something that gets shaded twice. That's what we're going to spend the next two examples looking at before we take a break. Alright, so first example. So since we have two inequalities, we do them individually, knowing that in the end, we should have something that overlaps. So x less than or equal to -3. Go to the x-axis, to a point at -3, and we should have a solid line. Should have a solid line. Now we pick a point to test. So somebody giving a point to test. Pick whatever you want. All right, -4, comma 2. So this is the point we're going to test. So again, I don't care what you pick. You just have to tell me what you pick and show me what happens. -4 less than or -3 is valid. That means everything to the left of that line is going to get shaded. So let's go ahead and shade that in yellow. So we're halfway done. Now we do the same thing for y is greater than 1. Go to the y-axis, put your point on 1. Since it's a greater than sign, you're going to have a dotted line. So now we pick a point that's either above that line or below that line. So, give me a point. Pick a point for me to test. 0, 3. 0, 3 would be above it. So x is 0, y is 3. Plug in the 3 for y. 3 greater than 1 is true. So that means anything above that line is going to be true. So I'm going to color above the line in blue. So we did our two shadings. Now we're looking for something that got shaded twice. You know, that rectangle right there. So that means all of our answers are in that rectangle. All the answers to this problem are in that rectangle. So I can pick any point in there and it will work for both inequalities. I can take any point I want out of there and it will work. That's it. Problem's over. select them both, whatever overlaps, that's your answer. Well, you have to shade the two parts individually to get the one that overlaps. So if you just shade that one part, then I'm going to wonder, how did you get it?
Do you just circle it or write -4, 2? Okay.
No, you just circle the region where all the answers are located. Because -4, 2, we use to test the first inequality. So the fact that it's just there is just a matter of coincidence. Any other questions? Example 1. Alright, let me give you a moment. So 4x minus 2y is less than or equal to -2. So if you're putting back that into slope-intercept form, move the 4x to the other side. And because you have to divide by -2, you still have to flip the sign if you're multiplying or dividing by a negative number. That's huge. So y is greater than or equal to 2x plus 1. Definitely don't forget that. So let's go ahead and start graphing. First inequality, -2x plus 3. Put a dot on 3. Down to right 1. Again, you want your lines to be as straight as possible. Use an ID, use a book. Produce a straight line. If you're having trouble drawing straight lines, I will gladly mail you a ruler. So, there's my dotted line. So now I need to pick a point to test. So, I'm going to pick the point 0, 0. Why did I pick that point? Felt like it. Remember, all I have to do is pick a point. It can be above it, below it, wherever I want, as long as it's not on the line. So if I test 0, 0, and if 0 is greater than -2 times 0 plus 3, 0 is greater than 3 is 100% false. So that failed. So since 0, 0 doesn't work, nothing down there is going to work for this line, which means I have to shade above. So if it's false, I can't shade it. Questions before we do the next one? do the next one. Same rules apply. Y-intercept is 1, up 2, right 1, for my slope. My sine is greater than or equal to, so I should have a solid line. Now I gotta pick another point to test. So I either want to point to the left of that line or to the right of that line. This time I'm going to choose, give me a point to pick. Give me a point that you use. Don't make it difficult, just give me a point. 4, 3. So 1, 2, 3, 4, 1, 2, 3. So as you can see, the more that you have on a graph, the more involved the problem gets, which means the more you have to pay attention to what you're doing. So let's test it. So 3 less than or equal to 2 times 4 plus 1. So 3 is greater than or equal to 9. Ha! No. That fails. 3 is not greater than 9. So, that means I cannot shade where that point was. I have to go on the other side and shade. So this is a 4, 3 is right there, which means I can't shade over there. I can't shade to the right of it. I have to shade to the left of it.
So if it doesn't work, you always just go to the opposite.
That's correct. So hopefully now some of you are starting to see you have to pay attention to what you are doing. There are 2 different lines on that graph. So go step by step. This is not something that you want to do at 1:30 in the morning when you're already half asleep. Because it's very easy to lose focus, get frustrated, all that other stuff. You got to pay attention to what you're doing. But there is a part that overlaps. That little triangle right there. So that's where all of your answers are located. So again, I plead with some of you, pay attention to what you're doing. Don't wait till the last minute to try to do the work. And make sure you go step by step. Because when I go to grade it, I'm going to check for every single step. I'm going to check to see, did you shade? Did you test? Did you draw the lines correctly? Gotta look for it all. Any questions, example 2, before we take a short break? What's your question?
So basically, you can't get it wrong.
Oh, you can get it wrong. Let's not get that twisted. You can get this wrong. You shade the first one wrong, then that's going to throw off and possibly give you a false answer. So you can get this wrong. And trust and believe, I'm looking for what's wrong. I'm looking for anything I can mark wrong. So again, don't wait till the last minute to do your work. Don't do it at 1:30 in the morning. And do it step by step. If it takes you 20 extra minutes to do it the right way, like my mama said, you have time to do it right, or you have time to do it over. One or the other. Go ahead and take. If there's an overlap. If there's no overlap, then there's no solution. So, go ahead and take the next 150 seconds, which is 2.5 minutes. We'll find something else. So now we get back to it. So, we did 1. We did 2. Now we'll do 3. The same rules apply. We're still looking for the part that gets overlapped. You just now have 3 inequalities to deal with. 5 less than 2x plus 5. X greater than 1. So again, it's do them one at a time. Do not try to rush through the problem. So 2x minus y less than or equal to 3. You have to get into slope-intercept form. So negative y less than or equal to negative 2x plus 3. So y is greater than or equal to 2x minus 3. You have to get into the slope-intercept form. So y-intercept is negative 3 up to right 1. Greater than or equal to means I have a solid line. So greater than or equal to means I want something that's greater than or equal to. So I'm going to test the point 0, 0. That's the point of the test first. When I picked that point, it felt like it, and I think that's what's going to work. We have 0 greater than or equal to 2 times 0 minus 3. 0 greater than negative 3. That's valid. That means 0, 0 works. Let's start shading first. So again, I'm using a highlighter that way I can still see the graph that I'm working with. If you are using a pencil, shade lightly. That way you can still see your graph. That's the first inequality. Second inequality. Y is greater than 2x. Y is less than 2x plus 5. 5. Up to right 1. Now, those of you who have already worked ahead with this problem,
Wait, aren't you supposed to use dotted line less than or equal to signs?
nope, use a solid line for less than or equal to, greater than or equal to. Use a dotted line for less than or greater than.
Oh, okay.
So you see that line underneath, that's an indicator that it's going to be a solid line. So, not a bad observation, though. So, I've got my second line. Now I need to test. I got to figure out where is it going to be less than. What point do I want to test? What point should I test?
Zeros.
If you use 0, 0 again, it's not on the line. It's not on that line, so you can use 0, 0 again. There's no rule that says that I can't use the same point for another inequality. No rule that says I can't. That's correct. So for that dotted line that we just drew, if 0, 0 doesn't work, we're going to shade on the other side. We're not going to go test another point for it. So we got 0 less than 2 times 0 plus 5. So 0 is less than 5. That's valid. That's going to work. So let me choose blue and shade on this side. So you should notice on the screen there looks like there's a little part in the middle is green. That's overlaps. And I still have one more inequality. Any questions before we finish the problem?
Can you say what the lines are again? Like if it's less than, so dotted or
Less than and greater than is dotted. Less than or equal to, greater than or equal to is solid. Alright, so for the third one, x is greater than 1, so this is going to be a vertical line. Go to 1, put a vertical line. It's going to be a vertical dotted line. So I just put a blue star by where that vertical dotted line is. So now I need to test another point. I need another point that's not on that line. And you know what? I'm going to use 0, 0 again. Because it's not on that line. As long as it's not on that line, I can use it as much as I want. As long as 0, 0 is not on that line, I can use it as much as I want. So x is 0, but 0 is not greater than 1. That's not valid. So, since it's not valid, I'm not going to shade on the left. I'm going to shade to the right. So this shade will be in the pinkish color. now we look for what was shaded 3 times. And I'm actually going to put it in black. What was shaded 3 times. So the shape that I just traced in black, that's the part that was done 3 times. That got colored 3 times, so that part's your answer. So it's not a hard problem, it's just a problem that takes some work. It's not a hard problem, it's just a problem that takes some work. Any questions on any part of example 3?
What would be the best way to show this on a test?
I would probably, you talking about the final answer?
Yeah.
I would probably take whatever part that was shaded 2, 3, however many times, and trace it in like a black marker, or just color it in. Color that particular part in.
Okay.
Yeah, for those of you who have colored pencils, markers, highlighters at home, feel free to use them. Feel free to draw an arrow that points to where the final answer is. Give a little bit of freedom, use it.
So the shaded black part is the final answer?
That is correct. That's the part that got shaded 3 times. Now, for the person that asked how would we indicate our final answer, on your quiz and subsequently on your test, the last question is going to tell you to pick a point that is in your answer area. So that would mean, since this is my answer area, give me a point that is inside of that area. Now that can be whatever you want. So for example, 1, 2, 3, 1, 2, 3, 4, 5. 3, 5 is inside of there. So my sample answer, 3, 5. So that's how I'll know whether or not you did it correctly. I'll take your sample answer and plug it into all of those inequalities. And if it works, then I know you did the problem correctly. If it doesn't work, then I gotta go find your mistake. Any questions before we work on the word problem? Alright, example 4. Mr. Lowe plans to purchase $5 and $10 gift cards for his students who earned A's and B's. He must buy some of each gift card, and he has a total of $100 to spend. Write a linear system of inequalities that shows the number of $5 gift cards and $10 gift cards that can be purchased. Graph the system and use the graph to determine 3 combinations of gift cards. So, there are 2 types of gift cards that I can buy. $5 and $10. No, this is not something that I do in real life. I will be broke messing around with all of you all who got all these A's and B's. So does not have time to be broke. But we're gonna let X equal the $5 gift cards. And Y equal the $10. So, a couple things to keep in mind as we read the problem. He must buy some of each gift card. So that means I can't buy no $5 cards or no $10 cards. So that tells you how to set up two parts of the problem. X has to be greater than 0, and Y has to be greater than 0. There's two of your inequalities. Why? Because I have to buy some of each. And I have a total of $100 to spend. So, a $5 gift card is $5. A $10 gift card is $10. And I have a total of $100 to spend. So, 5x plus 10y has to be less than or equal to 100. So I've used all my information. Any questions so far? Let's start graphing. So x greater than 0. Dot on 0, draw your dotted line. Now, since it's going down to 0, I'm probably not going to be able to tell that that's dotted. That's fine. You wouldn't be penalized for that. So x greater than 0. So we need somewhere that's greater than 0. We need to test the point. So I'm going to test 3, 3. Okay. Less than 3 greater than. 3 greater than 0, that's valid. So everything on this side is shaded. So that's the first inequality. Second inequality. Y is greater than 0. Dot on 0. Draw another dotted line. I need to pick another point to test. What do you know? It's 3, 3. I'm going to use it again. So y is equal to 3. 3 greater than 0. That's valid. So 3, 3 work together. I'm going to shade the color. So now I've got an overlapping square, and I still have one more inequality. X plus 10y is less than or equal to 100. second. So if we put it in slope-intercept form, that's 10y less than or equal to negative 5x plus 100. Divide everything by 10. Y is less than or equal to negative 1/2 x plus 10. Y-intercept is 10. Down 1, right 2. I can't go any farther. Come on. So I still need another point to test. Use 3, 3 again. And I can use the same point as long as it's not on that line. Negative 1/2 times 3 is negative 1.5. So 3 is less than or equal to 8.5. That's valid. So everything below there gets shaded. I have an overlap. So this is what I would do to trace my final answer. Trace it in black. If you can lightly shade it, that's okay too. So everything in there represents my final answer. So I've graphed the system. When it tells you to determine 3 combinations, pick 3 points that are inside of there and write them out. So all you do is pick 3 points. So 2, 2, 3, 3, 4, 4. So just pick 3 points. I'll put the rest of the stuff that I erased back up there when I post the notes. But yeah, working it out is not difficult. You just have to pay attention to each part.